All right, so this is an application of what we did last time. Um, so here's a real life situation. So a rock, you drop a rock from the top of, of a 450-meter tower. What is the velocity of the rock 5 seconds after it was dropped? Use this function, uh, which models the height of the rock with respect to time as it falls to the ground. So this is a real function right here, that it does actually measure how far it drops with respect to time. So you got that going like this. Let's do a graph for this before we get started. So come up and get a calculator, a ruler, if you haven't gotten a ruler, and copy this down so we can find the height. So now I had a student, and I was already thinking of doing this. That calculator that I'm giving you is so archaic, so old. You know that Desmos works much better than that calculator. So get your phones, and we're gonna find the height by using Desmos instead. I don't know if you have downloaded Desmos on your phone, but Desmos is way faster than that calculator that we have. All right, so copy down this graph. And then we're going to figure out, as time passes, where up in the air is the rock, the height of the rock. So get your calculators or your phone. I don't know if you downloaded Desmos already, but if you haven't, I'll download it. And we're gonna find these heights, and then we can plot them. So at time equal to 0, you're gonna plug it into for t, because t is 0, so it's negative 4.9, t is 0. You're gonna square it plus 450. That's really what's happening. So at time equal to 0, how high off the ground is the rock? Anybody? Loud? We're I'm at the top of the tower and I'm letting go of the rock. I'm not throwing it or nothing, even it doesn't matter. I'm letting it go at time equal to 0. It is 450 feet up in the air. So 0 square 0 times that 0, 0 plus that is 450. So it's 450 feet up in the air. Then we let go of the rock at time equal to 0, and then it starts free falling. So how high off the ground is it now? So you're going to plug in T is 1. So when you graph it, I'm already graphing it here. At time equal to 0, it is 450 feet up in the air. And at time equal to 1, it's going to be somewhere up in the air. So at time equal to 1, this one we could do it quickly in our heads here. Time is 0. Time is going to be 1. So if you plug it in, negative 4.9, T is 1. Square it plus 450. And that's going to be 1 squared is 1. Take away, that's going to be negative 4.9 from 450. That's going to be 445.1. 445.1. Okay, so now go ahead and let's use our calculator, the Desmos calculator. Let me just kind of show you. For those people that have, maybe I saw one person use it the other day, and I was like, that's smart. I gotta get out of this. Okay, so let me get out of this because again, this is not. So let me go now. Now I can go to Desmos. Look, Desmos is so cool. You can just like plug it in the function. It says negative what? Negative 4.9 and do parentheses and leave that alone. Get out. Square it, and then plus 450. And all you gotta be doing is just plugging in the numbers. Look, 0, it'll give you the answer. And you probably already knew it, maybe, I don't know. Gives you the answers. As opposed to be doing it over and over and over. So you already, so at time equal to 2 is 430.4. Okay, so yeah, this is the way to do it. At time equal to 3, 405.9. And you can just kind of plot the points. It's going to be a rough sketch. You can't really know exactly where it's at. So at time equal to 2, what did we get was time equal to 2? 430.4. At time equal to 3. Time equal to 3, what is it? Come on, somebody. Time equal to 3. 405.9. Time equal to 4. 371.6. Time equal to 5. 327.5. Time equal to 6. So here's what we got here, and then you can connect those dots, and you should, again, if you have, if you remember the pre-calc we did about quadratic equations, you know it's upside down because it's a negative parabola, so it's upside down parabola, and we just got the right side of the parabola, and then we got this graph. So I'm just showing you like this, but what we really need is S of 5 and 327.5. We don't really need these other ones. What we do definitely need is, what we definitely do need is a time equal to 5. We need this. And then go across and whatever that is, that's what we do need. So a time equal to 5 is 327.5. Again, like last time you guys were looking at this, and yes, sometimes the graph, it doesn't really exactly match what's going on here. So really the math is more important than here, because sometimes it doesn't even make sense, the graph here, what would it be? So anyways, so what we want to know is, what is the tangent line here, no? What is the slope here? And what we're going to do again to figure this out is do what we did last time. And have, this is how they do, they check for those that are, how they get you, the police get you for going over the speed limit, is that they quickly, they don't care what happened before, and then they quickly see you speeding, then quickly get the radar gun, and the thing, it just catches it, and then because of technology, it catches it a quick second after, and then it gets your rate of change at that time. So that's what we're gonna do. We don't care what has happened here. We just care about here. That's when the radar gun gets you, and then here somewhere else, and then get it closer and closer and closer, infinitely closer to this, so you can get the slope. So that's what we're gonna do. So we don't care about those times before. Let's do a 6. A time equal to 6. Okay, put it in your calculator. What is that time equal to 6? How high off the ground are you? 273.6. So we got those two. So we got, see, this is going to be the slope here, but that's the secant slope. That's not going to be it. We want it to get closer and closer and closer, and that's what we're going to do after this. So what we do have is that we do have, if we wanted the equation of the line, we do have already y minus equals and then x minus. So we got the point. The point, we have a time equal to, x is time, minus 5 seconds, and then the height at 5 seconds is 327.5. What we don't have is the slope. That's the problem, the slope. So that's what we're going to do right now. Find the slope. We're going to get closer and closer and closer until we get the slope. All right, let's start doing it then. We got everything else except the slope. So we'll go back to the problem, and we're going to set it up to try to find the slope. So the time interval we got from 5 to 6, no? And from 5 to 6, we're going to get the average velocity. Which is that formula. So we're going to do the average velocity. The formula was what? B minus A at the bottom, F of B minus F of A. Where A and B are those numbers there. A and B, 5 and 6. So B is 6, A is 5, so be 1, B. 6 minus 5 is 1, and then this is going to be F of 6 minus F of 5. All right, let's go down here. So 6 minus 5 is 1 at the bottom. Okay, what was F of 6? You guys wrote it down. What was F of 6? $270 what? 273.6. Minus F of 5 is 327 point. Is it? F of 5, what was it? 327.5. So so subtract them. That's going to give us our first approximation of the velocity. So it's going down, so it's a negative velocity. It's going at negative 54 about meters per second. Now, like I said, we're going to approximate, this is 5, and now we're going to get it closer and closer and closer. So we're going to do 5 and 5.1. All right, so average velocity, I don't know, velocity will be approximately 5.1 minus 5, f of 5.1 minus f of 5. Okay, so like I just said, decimals, go back to that decimals and plug in that 5.1. What is 5.1? Decimals, so it's negative 4.9, negative, parentheses, 5.1, square it, plus 450. Okay, so I'm getting, what are you guys getting? Okay, so we're gonna like round 322.6 minus f of 5 that we had already gotten, f of 5. 327.5, 327.5, and then it's gonna be 0.1 at the bottom. So go ahead and do 322.6 minus 327.5 divided by 0.1. Yeah, just get another one, leave the other one open, and get another one just to do this. 322 minus and then divided by 0.1. So what are you guys getting? So let's see. Anyways, so negative 49.5, and it's gonna start approaching some velocity. So I'm gonna go 5 to 5.05. I'm gonna do the same thing again. The velocity will be approximately 0.05 at the bottom. F of 5.05 minus f of 5. .05. Okay, so for 5.05, it's going to be 325 point. I don't know. See the rounding. Where do I round? Where do I don't know. 325, I guess, if it's rounded to nearest tenth, and then minus 327.5 divided by 0.05. So it's negative 2.5 divided by 0.05. Negative 2.5 divided by, no man, here's another one, Negative 2.5 divided by 0.05. I am getting, what are you getting? The heck? 0.05. What are you getting? Yeah, negative. Well, look. We need to, the rounding needs to be, probably get us to the thousandths place. I'm getting, so it probably we want to round to the nearest thousandth, or else it's just not going to be it. Let's do this one and round to the nearest thousandth. Let's go with velocity will equal to 0.01 at the bottom, the difference, and then f of 5.01 minus f of 5. So 5.01. I'm getting 327. So let me do this. 327.0095. I'm going to use all of this all of these numbers. Minus 327.5 over 0.01. All right. 327. .0009 minus 227.5. Divide that by 0.0. Hold on. How do you do this now? Divide that by 0.01. Yeah, I guess learning how to use the calculator is one other thing. I'm already stuck on how to use this. Anyways, so what would you guys get? So if you learn how to use the calculator, the answer is negative 49.049. And you could probably say, let me just give you the next one, 5.001. And the answer will be negative 49.00 something probably. Yep, negative 49.001. That you can probably say that the velocity will be what? 49, negative 49. So meters per second at time equal to 5. And with that information, then you can get the equation of the line, even go further, that at time equal to 5, you are 327.5 meters up in the air with a velocity of negative 49. All right. Moving on. So I'm going to tell you then, now everything we're going to do is going to be limits. So we're going to stop. This is very much calculus, and calculus is based off of limits. So now we're going to go off on and do limits. Go ahead and copy this down. So you got a quadratic equation. And what are limits? So we're going back to this quadratic equation. So there's 3 different cases. Case 1, case 2, and case 3. What happened to the 3 over it? All of these ones, let me just focus on case 1. Case 1, you got this quadratic equation that is continuous. Continuous means that you can draw the parabola without lifting the pencil. It is continuous. It has no holes. It's continuous. Yeah, it's defined everywhere for all reals. So this one is going to have a limit for sure. And if I ask you, what is the limit as x approaches? Let's see, we'll do it in a minute. But the question is this: what's the limit as x approaches 1 of this function f of x? And it is a quadratic function. So what's the limit as x approaches 1 of f of x? And if we can have the Brian come up, and but we're not, come and draw his little car again like we did 3 months ago, and he would have his little car driving around, and he had a little car, but I can't even drive. No, actually, he had a little buggy like that. And then I say, hey, he's driving down. The limit as x approaches 1 from the left and from the right, but coming from the left, we're driving, and we're approaching x is 1. This is x is 1. X is 1. So as we get closer and closer, what is the y value? What y value are we approaching? And what y value are we approaching? And the answer is 1. So the limit as x approaches from the left is going to be 1, and coming from the right, it also is going to be 1. We got the car going, and we're driving, we're going, and it is 1. So the limit is 1. So this particular one, there's nothing wrong with it. The limit is the y value is 1. So the limit as x approaches 1 is 1. But what happens when the road, imagine then again this is a road, and there was this engineer who was not able to fix the road. The road is messed up, and they said, hey, go put the pothole, fix that road. And instead of putting the pothole and filling it in, it still has a hole. He put it way over here. He doesn't even understand how to where the coordinates to go put the hole in. So this is not a continuous function. So, but it's okay still. As what's his name? Brian is driving with his car, and he's driving. He doesn't know that there's going to be a problem there. But who cares if there's a problem or not a problem? Here is that we're approaching it, and we're going to approach the y value of 1. It doesn't matter if whoever engineer has it completely filled in or not. So same here. Look, if we're approaching, there has been no problem. But from the left and from the right, we're approaching 1. The limit is still 1. This is the limit is still 1 here. This is fine, even though it's not defined at 1. And what do we got here in the last one? It is not defined at all. Say there was a pothole, and nobody went and fixed it, and then it's still neglected. It still doesn't matter, because as we approach it again, as we get closer and closer, the y value is 1, and they all have the limit of 1. So the limit is we're approaching something. Okay, now here's where pre-calculus, understanding pre-calc and calc. The function of 1 for this particular one here, the function of 1 is 1. So it is defined for an input of 1. The output is 1. So this is the output is 1. It is defined for the input, and the output is 1. All right. Ah, man, you're getting this. I know, Brian, you're getting this. Brian, for case number 2, what is f of 1? Everybody, give them a chance to think. For case number 2, what's f of 1? 1. So for case number 2, f of 1, are you that engineer and you're like, oh, yes, I did it and I fixed the pothole? No, you didn't. You put it in the wrong spot. Brian, where did you put it at? You put it at 4, Brian. F of 1 is 4 in this situation, but you were supposed to put it here so this thing could be continuous. So f of 1 is what? In this situation, f of 1 is what, Brian? 4. In case number 3, which is missing 3 here, case number 3, Evelyn, for case number 3, what's f of 1? Anybody, give it a guess. What's f of 1? Undefined is correct. Undefined. It is not defined. Yes, it's undefined. Unless somebody, they're like, no, actually it was defined here. You don't see it. Now, be quiet. All right, it's, for all we know, is undefined. Yes, it's undefined. This concept is not what I just did about limits. Limits is an actually moving and getting to it. So now, here is the difference. And I just went over this, and I'm going to do it one more time. The limit as we approach 1 of this function is 1. The limit as we approach it is 1. The limit as we approach is 1. For all of these, the limit is 1. What y value do we approach as we get closer and closer to x equal to 1, coming from the left and from the right side? And the answer is 1. The limit as we approach 1 from the left or from the right, the answer is 1. And the limit as we approach from the left and from the right, for this case over there, number 3, is 1. If you don't get this, you can go to the website and get anything you're missing, because I gotta get going. All right, so we're moving on. For all 3 cases, the limit as x approaches 1 is equal to 1. For all 3 cases, the y values are different at x equal to 1, but they have no bearing on what the limit is, which is 1. All right, moving on. We're gonna check for understanding. What? You don't have to copy this down. I don't know what to check for understanding. You don't have this particular one. You don't have to check. Oh, what happened to? Who's that? F of 2. Gio, what's f of 2? 4. F of 2 is 4 is correct. F of 2 is 4 is correct. Yes. Looking at the middle graph. Looking at the middle graph. Hold on, don't say anything. Andrea, what's f of 2? For the middle graph, f of 2 is what? Loud. Huh? 1? That is correct. It's 1. For the last graph, f of 2. Evelyn, what's f of 2? Undefined is correct. Yes, okay. The limit as x approaches 2 for the first graph, the limit as x approaches 2 of the first graph. Diego. Loud. the limit as x approaches 2 of f of x for this first graph. Brian, let him borrow your car, please, so he can start driving. So Diego, you're gonna drive Brian's car, and then you're gonna start drive whatever. You're gonna start driving, and then you start driving, and you're gonna approach 2. You're gonna approach 2, and then so you're gonna go approach 2. So you're gonna go like driving. What y value are you approaching as you get closer? I don't even care if you get to your final destination, and we don't. So you're driving from the right. If from the left and from the right you're approaching the same y value, then the limit is 4. What's the limit as we approach for the middle graph? The limit as we approach x approaches 2 of the function. What's the limit as x approaches 2 of the function? Becky. For the middle graph, the limit as x approaches 2. Loud. 4 is correct. Brian, finish it off. Last one. The limit as x approaches 2 of f of x. Last graph, the last graph. That is correct. That is correct. If you want to copy this down, it's going to take a while. You can go home and copy it down because we're going to get done with this lesson. All right. So now I'm going to ask people, look at it up there, look at the graph, and then I'm going to ask people randomly again. Look at the graph. Skyler, what is f of negative 3? Look at the graph. F of negative 3. 0 is correct. 0 is correct. Stephanie, what's f of 0? Loud. Huh? Negative 2, you said? That is correct. Lorena, f of 1. You said what? Undefined is correct. F of 2. F of 2. Leonardo, f of 2. Don't get limits with pre-calculus confused. Limits is like you get in a car, but what f of 2 is just boom. Is it there or is it not there? So what's f of 2? 3 is correct. Now we're doing limits. So the limit as x approaches negative 3 of the function, the limit as x approaches negative 3 of the function, you are getting on a car. 1, what is it? The limit as x approaches negative 3 of the function. Huh? Let me explain. The limit is the y value as we approach that x, the x number, negative 3. We're approaching -3. You get on the car and you drive towards -3. You drive towards -3. You're getting towards -3. And then from this side, you're driving towards it as well. And then are we approaching the same y value from the left and from the right? Yes or no?
Yes.
That's all. The limit as x approaches 0 of f of x. Natalie? The limit as x approaches 0 of f of x. You're getting on a car. You're approaching 0 from the left and from the right. Huh? Brian, you think you got it or what?
What if the car breaks down?
No, it will never break for you. It'll never break down, man. You'll get there. So what is it? See, I'm gonna be like, it's not that hard and whatever. Look, man, where's your car? Your car is gonna get to 0. X is 0 here. So your car is driving to get to 0. And this other car over here driving to get to 0. What do they approach the same y value from the left and from the right? That's all. The y value is the limit. -2. So yes, sometimes the limit and f of 0, they are the same sometimes. Sometimes they're not, and sometimes. So G. The limit as x approaches 1 of f of x. Janet. Loud. -1? Is that what you said? It is -1. The limit as x approaches 1, so you're coming from the left and coming from the right. It doesn't matter what this is. Well, eventually we'll be like, but who cares if it's defined or not defined? We're approaching -1. So it is -1. The limit as x approaches 2 of f of x. The limit as x approaches 2 of f of x. Maria. The limit as x approaches 2 of f of x. What? What the heck? What are you looking at? No. No, look at the question. Look, the limit as x approaches 2 of f of x. You guys don't like my car analogy? I thought it was like the simplest way of teaching it. What y value are we approaching as we come from the left and from the right to x equal to 2? What is it, Brian? It's 2. just to finish it off, here's the last one. Oh, I'm going to come up with one. Limit, what the heck? The limit as x approaches 4 of the function f of x. What's the limit as x? No, 4. Okay, actually, why not? But I was thinking something else. But anyways, why not? Who's that going to be? So Yuri, what's the limit as x approaches 4 of f of x? 1 point something, 1.1 maybe, 1.1. Yes or no? Yes? Yeah, you get it now? That makes sense? And then I was limit as x approaches what? X approaches negative 4. That's what the one I wanted to do. The limit as x approaches negative 4 of f of x is going to be what, everybody? 2. That's it. All right, we're done for today.